The other time we talk about linear combination, right? Okay, in a linear combination, maybe I got, uh, you know, let me first write a linear combination. Okay, linear combination. Now take a look at this. If I have something like this, okay, I actually have a random variable x, and this random variable s as a moment generating function. Okay, the a and b here, okay, are constants. Where a and b are constants. Okay, now I want to find the moment generating function of y. Okay, I want to find the moment generating function of y, and don't forget y is a linear combination. Okay, x is a random variable. The x as a random variable has a moment generating function itself. Okay, so which means what I actually want to do, okay, is expected value of e raised to power t y, okay, which is going to be expectation e raised to power t. What is my y? My y is as plus b. Okay, please pay attention. Pay attention what I'm trying to do right now. I'm trying to find the moment generated function of a linear combination. Okay, now when you take a look at this, I want to expand this guy right now. Okay, if I expand that guy right now, so I'm actually gonna have, let me say that guy first, TB, okay, and plus TAS. Okay, now if I if I want to rewrite this, I can rewrite this as this. Okay, when I write that at that, then I'm actually gonna have, okay, so when you take a look at what I have here, TAS, okay, initially it was exponential raised to power TS. Okay, so right now, so I'm actually having TAS. So if I want to now finally want to rewrite that, okay, I'm actually, you actually gonna see that I can now write AS, I can write X, then AT. Look at that. I can write this as this. Okay, now take a look at this. This guy now is this guy. Okay, I want you to take a look at this guy. Okay, exponential is power TAS. Okay, don't forget exponential is power TS. Exponential is power TS. Okay, exponential is power TS is ms of t. So if I now add another, if I have a, okay, then it means apart from s, I'm actually going to be having a t. So that was why here I got a t. So this is this expression now. Okay, this is actually going to give the moment generating function of y, where y is a linear combination. Now, another thing that I want to do right now, okay, another thing that I want to do right now. So another thing that I'm gonna do, let me look at my time. So I'm gonna spend like, okay, now another thing that I want to do right now, okay, let's say y equal x1 plus x2 plus x3 dot 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 until we get to Sn, okay, and I want to find the moment generating function of y, and the moment generating function of x1, x2 up to xn exists. Okay, if I want to do this right now, okay, so this is the my of t here, okay, is going to be expectation of this guy, y, right? And which is going to be this, t, what is my y, okay, is x1 plus s2 dot 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 until I get to xn, okay? I just wanted to take a look at what I have here, okay? So let's take a look at this guy right now, okay? So I'm actually gonna have e raised to power t x1. Okay, mathematically speaking, I'm actually gonna have this until I get this. Who doesn't understand that? Because when I combine this, I'm gonna have the power, right? Okay, now what is the implication here? Okay, what is the implication here? Okay, the implication now is that I can write that as this, okay, multiplied by this, okay, dot 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 until I get to this. Okay, so what am I trying to showcase? What I'm trying to showcase right now, this is actually if I can write a product. If I want to write it in short form, then just gonna have write this guy now TXI. Okay, and I can also rewrite this as having this. I start from one to that MXI of T. So what is the conclusion here? The conclusion here now is the moment generating function of the sum of a random variable, okay, is the product is going to be the product of the respective moment generating function. So this is a theorem in statistics, okay? The moment generating function of the sum of a random variable is actually going to be the product of the respective moment generating function. I can write this guy as y is summation x, okay, summation x of t, okay, as well. Okay, don't forget. If I want to write this guy in short form, I can actually write that as this as well. So this is a theorem in statistics. Okay, now in a situation, I just want you to listen now. In a situation where the x1 up to, this is only possible in a situation where x1, x2 up to xn are independent. Okay, if they are independent, even if they don't follow the same probability distribution, this is going to hold. I'm going to say that again. Please pay attention. Please pay attention. It's very, very crucial. What I just demonstrated right now is, okay, I want to figure how the moment generating function of a sum of a random variable, why equal to that. Okay, what I've just established right now for situation where x1 up to xn are independent. If they are independent, then the moment generating function of the sum is going to be the product of the respective moment generating function. Okay, my assumption here is you're multiplying them. It doesn't really matter whether they follow the same distribution or not. But let me tell you this. Let's assume that they are identically distributed. If they are identically distributed, I'm going to show you something now. Please pay attention. Pay attention. Okay? If they are, let's say x1, x2 up to xn are identically distributed. Identically distributed means they come from the same distribution. This guy is actually going to be written as this. Does that make sense? Because in that situation, each of them will be the same. If they are all the same and you have it in n term, then you just write a moment generating function, you raise it to power n. And I'm going to give you an example right now. Okay, an example can be found, with a connection between Bernoulli and binomial. Please pay attention. Okay, now take a look at this. Let's say I want to have an example right now. Okay, let me first start from Bernoulli.